in the first module. So first of all, at a high level, let's talk about the different capabilities that the Azure Machine Learning Service provides to us. First of all, we get the ability to register our data. And then based on the data, we can go in and perform experiments to help validate the hypothesis that we have. Then we gain the ability to evaluate and store our models, and ultimately we can then deploy our models, which enables us to operationalize them. So let's take a look at each of those. In terms of registering our data, it gives us the ability to leverage both private data, so data from your organization, as well as public curated data sets. And the public data sets are especially valuable when you're learning data science. It also provides the ability to create reusable pipelines for data preparation. Now, we will not be walking through that in detail in this module, but we will be going through this in a future module. It also gives you tools to pull data either from Azure or from outside data sources. And it provides drag and drop tools for even creating these data pipelines. Then, coming out of registering our data, we have performing experiments. Now, one of the big benefits that the service provides is its access to compute power. And we can leverage both CPU and GPU-based infrastructure for our experimentation. And in doing so, we also can enable dynamic scaling, so that if we want to grow based on our needs within our cluster, or if we want to shrink it when we're not using it, we gain that ability so we're only paying for what we need at any point in time. There also is wide range support for popular machine learning frameworks. And this is important because we're looking at frameworks here like TensorFlow and PyTorch and scikit-learn, things that enable you to get up and running quicker if you're working within those frameworks. However, it does enable deep customization of both the infrastructure and the framework support. So if you want to do something that's very custom, that's not what is normally done out of the box, you do have the capability to do that here. Now, as mentioned, we have the ability to evaluate and store our models. So it does provide centralized model storage within a workspace. Now, this model can either be from your local experimentation, so using local compute, or on your compute cluster, so remote compute. It doesn't matter whichever one it's from, you can store your model. It doesn't even matter if you're using the Azure Machine Learning Service. You can choose to do experiments entirely on your own computer and then upload your finished model. And then from these models that are stored, you can then deploy them. And some frameworks, the popular frameworks that we mentioned, support zero-code deployment. So simply from your model, you can deploy those and operationalize them. But most any framework can be supported. You may just have to write some custom code. And this enables inference to be available, either via the Python SDK or a REST-based endpoint, and we'll be validating both of those in this module. And you can run these on Azure container instances or the Azure Kubernetes Service, AKS. It also supports IoT edge deployments, which is a powerful feature, but not one that we'll be covering within this course. So let's take a high-level look at Azure Machine Learning. It starts off at the high level with our workspace, and we created a workspace in the initial module in this course. Now coming out of here, and this is an abbreviated list, but we have several components. We have our compute targets, which can be local or remote. We have experiments, and this is where we begin to build out tests that validate our hypothesis. We then have pipelines, and then we have a place where we register our models, and then we have our endpoints that have been deployed. So underneath experiments, we have runs, and runs are individual passes of our experiment. And we might have 100 runs for a single experiment, for example. And pipelines also feed into runs, and we'll talk more about that in an upcoming module. But out of runs, we get outputs, things like our model. We get metrics, like our accuracy rate, and we get logs based on the process. And then out of endpoints, as mentioned, we can have our web service endpoints. We also can have IoT edge deployments. So in this course, we're going to be focusing primarily on web services. Now let's look at how we interact with Azure Machine Learning. We have several options. In the first module, we looked primarily at working within our IDE, and we also could have looked at using the CLI, but basically interacting with Azure in a completely programmatic way. You also have the ability to interact with Azure Machine Learning in the browser, and we'll give some caveats to that in just a minute. And then you also have the ability to work within a Jupyter notebook. Now, in this module, we're going to start working in Jupyter notebooks, but everything we're going to do, you could do within your TDSP project template that we created in the first module. It's simply a matter of just running the code there as opposed to running it within your Jupyter notebook. Now, as mentioned, we need to talk about browser access for Azure Machine Learning. There are two different interfaces for the browser. Now, Azure Machine Learning in the portal provides most all of the management functionality that you would need. But we also have Azure Machine Learning Studio, and it's currently in preview. And here we're talking about the new version as opposed to the classic version. And it provides some advanced tooling for in-browser training. So this is where you can design models with drag and drop components just within your browser. And in most cases, you're going to leverage both of these experiences within your projects because there are some pieces of functionality that are only available in one or the other. And so we'll be accessing both. Now, just a quick reminder about Jupyter Notebooks as a whole. They do enable easy experimentation for data scientists, and we're going to look here at a way to create them within the new Azure Machine Learning Studio that makes it easy for us to work with them. It also minimizes the need for configuration and environment management. And the Azure Machine Learning Service does enable notebook virtual machines, or VMs, that we'll be leveraging. We'll be spinning one of those up within this module. But it can be less effective when working on team-based projects, and this is why the TDSP template that we created within the first module is essential, because if you're walking away and working with a team, that's the approach you'll want to take for anything that needs to live within your team project.